Welcome to the City of Akron's water reclamation facility. This facility processes an average of 77 million gallons a day. What you're looking at right now is what we call the main outfall interceptor. That is the main pipe that brings all the flow into the plant. Our peak flow in a rain event can be as high as 280 million gallons a day. Right now, the flow, I have an app that I can look that up on, is 56 million gallons right now. So it will continue to go up during the day. It's what's called a diurnal flow. The flow goes down at night and up during the day when industries are open and whatnot. We also treat more than just the city of Akron. So there's about 200,000 people in the city of Akron, but we treat the equivalent of 330,000 people because we treat the surrounding communities, Cuyahoga Falls, Talmadge, part of Mogador, Lakemore, Springfield, parts of the county. All that flow comes here. And then the reason that the flow can go from an average of 77 million gallons a day to 280 million gallons a day is because we're a combined sewer community. So anytime it rains, there are portions of the city which have combined sewers, and that means that the rainwater and the sanitary sewer are combined together and that it all comes here. The flow can go up very quickly. I've seen the flow go from 70 million gallons to 200 million gallons in 45 minutes in a heavy rainstorm. So the building that's right behind us here, that is our screenings building. So once all the flow comes in, it is split into 4 channels and we have 4 screens. They're gonna pull out debris. So let's go inside and see what they look like. So this is our screenings building. All the flow that comes in here is filtered through these screens. They are Parks and AquaGuard screens. They pull out everything larger than 6 millimeters or 1/4 of an inch. So any debris that comes into the plant is then pulled out. It goes up these screens, which run on a timer to save wear and tear on the equipment. It goes onto a conveyor belt. Once it's on the conveyor belt, it goes into a compactor where we dewater it, and then it is sent to a landfill. One of the biggest problems that we have in this process are flushable wipes. Yes, they're flushable, but they are not good. They blind equipment and clog pumps. In fact, there's one right here on the screen, and you can see how it flattens out on the screen, and it will blind the screen out, and it makes the screen less efficient. So this is the back side of the screens. You can see screen number 1 down there is starting to drop stuff on the conveyor belt. It goes down this conveyor belt, and that's where the compactor is at the other end. There's also a round machine down there at the end. It is a rotary drum grease strainer. And when we get to the primary tanks, you'll see the grease on the tanks. We pump that back up here. It is dewatered, and then that is combined with our screenings, and then that is also sent to a landfill. Once everything comes through screenings, it then comes to our degritting process. So we have 4 grit tanks, and the way grit tanks work is the flow in the system, you want to flow at 2 feet per second to keep everything in suspension. So you bring it to the grit tank and you slow it down to about 1 foot a second. And what this does is it allows all the easily settleable inorganic solids to fall, to settle to the bottom. And then there's a rake arm that pushes it into a hopper, and then it goes up a screw where we dewater it. And so this is going to pull out sand and gravel and things like that. And we do that to protect equipment because it's not good for pumps. It's very abrasive on the system. And so screenings is also doing that. It's pulling out large debris that can cause damage. So these 2 processes here are very important for protecting the rest of the plant. So let's go over and see the kind of things that come up in the screw. It is dewatering, so this rake arm under the water is pushing it all over towards the screw, and then the screw pulls it up. It goes onto a conveyor belt, and it is also disposed of at a landfill. So once it goes through the degritting process, it then goes back into a common channel and goes through that building right there, where we have 4 Venturi meters, and that's where we meter all the flow in the plant. So that is original to the plant when it went online in 1928. The flow has been going underneath that building this entire time. So we're going to walk down. The next place that we're going to go to is our primary tanks. and we're going to talk about what they do. Underneath your feet right here in this walkway, this is where all the flow is going to the primary tanks. And there's a set of gates right behind me. This is our storm retention tanks. So before, when I mentioned about being a combined sewer community, when the flow goes up, we have the ability to fully treat 220 million gallons a day. So if the flow gets above that, we will divert flow into this channel, and it goes up the screw pumps back there, and it goes into a storage tank in the back, and then we will pump that back out later in order to give it full treatment. The tanks are repurposed Imhoff tanks, and that was the original process from when the plant opened in 1928. And so we are still using them. You can see there's a little construction going on. They are being modified as part of the construction that's going on here, but we are still using them today.
Come down the channel here, we walk down here, and this is our primary split. So we have two sides to our primary tank. We have an east side and a west side. And each side has 12 tanks, and there are 24 tanks total. And this is the first time you can get a really good look at the flow. And you can see how it's a dark grayish color. I want you to remember that color later on when we get to our secondary process to see how much it's changed. So the side we're looking at right now, this is going to the west side. So let's go over and look at the west primary tanks.
So these are our primary tanks. Like I mentioned before, there are 24 of them. And this process here does two things. One is it removes easily settleable organic solids, which is called primary sludge. And it also removes oil and grease because it'll float to the top. And so before I said, 2 feet a second in the sewer system to keep everything in suspension. Then you take it to 1 foot a second to get the grit out, that inorganic solids. And then when it comes to the primary tanks, we try to slow it down to 1 foot a minute. So we're taking much slower. And you remove 50 to 60% of your organic loading from secondary here. And then it also pulls the oil and grease to the top. And so we'll take a look at what the oil and grease looks like in a second. We're going to walk over and look at tanks 2 and 3. The effluent side of primary tank 3, and you can see all of this oil and grease right here. That's all oil and grease that's been put into the sewer system. This has to be cleaned every day, and so someone has to come out, they turn a pump on, and then you have to push down the trough, and then it will pull all this grease off the top. We grease about every day, so this is just a buildup from yesterday. And so, one of the worst things you can do is put oil and grease down the drain. One, it clogs your pipes, and two, we have to deal with it here and remove it daily. So this is one of our primary tanks. This is primary tank 12. It's being drained for inspection today. And so you can see how the system works. When that sludge settles to the bottom, these flights move across and they push everything underneath our feet into a sump where it's pumped out. And then the flights continue their way back across the top, and that's how it pushes all that oil and grease down to the other end. So you can see they're not very large tanks, but they do a very important job for us. So this is what we call our console facility, or office. This is sort of like the brain of the whole plant. So a large portion of our plant can be run remotely with what's called a DCS system. This DCS system is monitoring upwards of 5,000 data points every second. And you can control a majority of the plant just from this room. So there's somebody stationed in here all the time. They keep trends up to make sure equipment's running properly and we're not having problems. We also have cameras in the plant so that we can monitor equipment, monitor processes remotely. We also have a special, I don't know what to call it, weather site that we go to through AccuWeather. We are a CSO community. The weather can impact us greatly. So we always want to know if there's rain coming, anything like that. So if we need to get additional staff to work at the plant. And then you'll see the screen right next to it. This screen here represents the basins that we've built in the system as part of our CSO long-term control plan. And so the operator that's in here can monitor each of those basins remotely without having to go out there. And then also, as part of our basins, we have this system here called a real-time control. And real-time control is a computerized system that helps us make decisions on when to dewater basins based on flow. And so you can see each one of the racks that's up there. It's also showing us levels in the collection system. And so we can make decisions on priority for dewatering each one of the basins after a rain event based on information that this is giving us. And then we also have this iFix computer here. So this is different than the DCS system on the other side. And this allows the operator that's in here to monitor all of the pump stations in the entire collection system, and that if there's an issue, they can call a crew and tell them that there's a problem.
So this is the primary effluent. So after all the flow's gone through the 24 primary tanks, the flow comes through here and it goes to our secondary treatment system. So up to this point, everything we've done has been some form of manipulating flow velocity or mechanical treatment. So the screens pulled out stuff, the grit tanks remove stuff, the primary tanks remove stuff. Now we're going to go into our secondary treatment, and this is a biological treatment. And this is where we use bacteria and metazoans and protozoans. And they're going to consume all of the dissolved nutrients that is left in the wastewater, because we've removed all the big stuff. And so you've got to think about it like making Kool-Aid. You put the flavor packet in, you put a bunch of sugar in. I got to get the sugar in the flavor packet back out again, and I use microbes to do that for me. And there's a big white pipe up here, and this big white pipe provides air to our tanks, because all of those microbes I mentioned are aerobic. They need oxygen to survive. So this is one of our biggest costs here at the water reclamation facility, is pumping air. We can pump 20 million cubic feet of air a day through that pipe. And that's just to keep all of our bugs happy, keep them alive, and keep them working for us. So when I said, pumping millions of cubic feet of air a day, we do that. We have 4 what are called centrifugal blowers, and we run one of those for base load. And then we have 4 of what are called ABS turbo blowers. And these blowers are much more modern and much more efficient. Running these blowers saves us energy because they don't have mechanical bearings. They actually have magnetic bearings. So the blower is floating on a magnetic field, so you don't get the friction loss. So this is one of our mixed liquor tanks. The mixed liquor tanks are comprised of 4 passes. So it's sort of like a serpentine, like when you go to Cedar Point. So the flow comes in here, and you can see the flow coming in is that color that we saw at the primary effluent. And then it's mixing with the mixed liquor that's in the tank. And we'll look and see how that mixed liquor gets back into the tank in a minute when we go to the final settling tank. But the bugs that are in here that are working essentially are returned back into the tank so they can keep working. We also waste some of them away, because for every pound of nutrient that we pull out, we create about a half a pound of new bug. So if we didn't get rid of some consistently, then the tank would just fill up with solids and it wouldn't work correctly. So there's the 4 passes, and then there's also 2 things occurring in here. So the first half of the first pass, if you look right here, you'll see there's no air bubbling. This is an anaerobic zone. And so what we do here is that the bugs that are brought back into the tank, they're rested, they want to eat, so we give them a bunch of food, but we don't give them the oxygen that they need. And so what they do is that they will attack phosphorus, specifically PO4, and which is phosphate, very common in water, in wastewater. And so they will remove the oxygen off of that so that they have oxygen. And so in this zone here, this is for biological nutrient removal. Then we put it goes through past the baffle wall down there, and then we put air in again, and so we give them oxygen. So now they have food and they have oxygen, and then they will start breaking down other nutrients that are in the wastewater. Each one of these passes is 300 feet long. On an average day, it takes about 6 to 8 hours
for the time the wastewater comes into the first pass and leaves the fourth pass. Now, because there are 4 passes, we have the ability to do something called step feeding. And so step feeding is a technique that we use when we have a high flow. And what we do is that when the flow starts to go up, we will start adding flow to the first pass and the second pass. And so that allows us to put more into the tank, because when the flow goes up in a rain event, the wastewater is more diluted. And so it doesn't take the full 4 passes to treat everything. And so that in plug flow mode, which is where it just comes in this first pass, we can treat up to about 130 million gallons with full treatment. But using step feeding, we can fully treat 220 million gallons a day. So we're treating more of that combined sewer and keeping the nutrients out of the environment. So once it makes it through all 4 of these passes, each one of these tanks has 3 final settling tanks or final clarifiers. So let's go over and look at one of those, and we can see the color of the water. I want you to remember from before when we looked at that primary split where it had that grayish color, and then this color here where it's still sort of dark. And we're going to take a look at what it looks like after it's gone through this treatment and after it's gone through the final settling tank. So after the flow goes through all 4 passes of the mixed liquor tank or the aeration basin, it then goes to the center well of this final settling tank. And so this is where our bugs can start to settle out so that we can remove them back. And the way they settle out so easily is because they form something called floc, F-L-O-C. And you can think of it like little clumps of bacteria. And so when you get a good floc form, it has a higher specific gravity, so it makes it heavier than water, so it settles very quickly. So once everything settles to the bottom, this collector arm right here is actually sucking out the sludge from the bottom of the tank that's settled out so that it can be returned back to the aeration basin. And I want you to look at the water that's coming over this weir right here. You can see how much cleaner it is, how clear it is, as compared to the color that we saw before. Now the mixed liquor that settles to the bottom is going to be returned back to the aeration basin. The water that's going over this weir is then going to be seasonally disinfected and returned to the environment. So all the flow from the 18 final settling tank comes through 2 pipes. There's an 84-inch pipe and a 96-inch pipe, and they combine in this. It's called junction chamber number 3. Once it comes in here, it's going to go back to the north again, and we seasonally disinfect using sodium hypochlorite. Right now, it is disinfection season because it's recreational water season. So we are injecting sodium hypochlorite here, and that's to get rid of any E. coli that would still be remaining in the effluent. It then goes into our chlorine contact tanks here, where it has about a 45-minute detention time under normal flow. And then we use a chemical called sodium bisulfite to remove any chlorine that might be left in the effluent so that it's not introduced into the river. Because we wouldn't want to negatively impact the river. We just want to get rid of any E. coli that's in there. So let's walk down and we'll see where we remove the chlorine from. And then we're going to take a look at where our effluent goes into the Cuyahoga River. So this is the effluent weir from the chlorine contact tanks. And then the 2 gray pipes going down, those are aerators. And that's how we introduce the sodium bisulfite into the water. It actually aerates it through it. And we remove any chlorine that's left over. And then it goes from there out through a tunnel and out to the river. So this is our outfall. So all the flow from the plant leaves here, and this is where it is returned to the Cuyahoga River. You can see how nice and clean the water is. We are consistently cleaner than the Cuyahoga River. And during very dry summer months, we could be a large percentage of the flow of the Cuyahoga River heading to Cleveland.